Hello, College Algebra. Today we're going to be talking about section 1.7, which is inequalities. And there are three different types of inequalities that we're going to be looking at. So one is the linear inequalities, and then three-part inequalities that deals with linear inequalities again, quadratic inequalities, and rational inequalities. So let's get started. Here are some properties of inequalities in case you may have forgotten. Remember that in an inequality, whether this is a less than or greater than symbol here, we can add to both sides of that inequality a value, just like it states here. That's all it's stating is we can add or subtract. And this sign right here, whenever you add or subtract, it does not change direction. If you remember, that's what these last two things are about here, these last two properties, is whenever you multiply or divide by a negative value on either side of the equation, what's going to happen is your sign, see in this number 3 here, your sign value changes the direction of that inequality. So that's all that is stating here, and we're going to move on to the next slide here. Okay, one thing we're going to be talking about are linear inequalities, and linear inequalities have this form right here, and all this is stating is that all of our linear equalities, the highest power on it is going to be 1. We'll be looking at quadratics and other sorts of inequalities too, but so far these first two examples are just linear. All right, before we move on to our first example, one thing new that is to everybody here in College Algebra that I've never taught in any other algebra class in high school before is something called interval notation. This stuff that you see in this column right here, interval notation. You may have studied set notation in class before, but we're mainly going to be writing in that interval notation. And let's see. So for an open interval, open means that these inequality symbols right here, they don't have an equal to symbol to it at all. And so here we have x is greater than a, and the interval for that is going to be a parentheses rather than a bracket like you see down here. And with your beginning with a, and then it goes on to infinity. So starting at a and going to infinity is how that interval looks there. And it's how it would look on a graph too. If you were to graph your certain function and try to find a certain interval, you'll see that. All right, this next one, it says a or x is between a and b. That's what that states right there. So interval notation is just in parentheses right here, and you would state your a and your b, and that's the values your x value is between. And see on a graph right here, that's how it would look. And then last on this open interval is x is less than b. So all values less than b, so your interval ends at b, but it's less than, all the values less than that, so you have to account for all the negative infinity. Other intervals that we'll be looking at are right here. And this just shows that whenever we have a equal to symbol, it changes our interval notation just a little bit. So if we have x is greater than or equal to a, then what that changes from up here to down here is we put a bracket around our a, because that value of a is included in our interval is what that means. Same goes here in this interval. See how this symbol right here that goes along with a, this right here means the value of a is not included, but the value of b right here is included. So we put a bracket around it. So anytime it's an infinity symbol, in interval notation here, or if the value that you know is not included because it's either stated as a less than or a greater than symbol, no equal to, you put a set of parentheses around it rather than brackets. Okay. All right, so here's some other types of intervals. So we have a closed interval. It's when you have x's between two values and it's greater than or equal to symbols on both, and that's how it's going to look, brackets on both sides of a and b. And then there's this disjointed interval where you have, looking at this graph right here of what it would kind of look like, you have values of a, but all of them are less than a or greater than b. There's nothing in between here. So how you would write that is just like this. So all values less than a, so negative infinity to a. And then you say this symbol right here is a union. And then you start back up with your value of b and it goes on to infinity. That's what that states there. And how we're going to state all real numbers in interval notation here is this right here, negative infinity to infinity. That's all real numbers. Okay, so let's move on to our first example. All right, so here's our first linear inequality. And how we're going to start this one out is, I'm just going to say, let's subtract 8 on both sides of our equation. And when we do that, we get a negative 5 minus 4x less than or equal to 2x. And then now I'm going to say let's add this 4x to both sides. And we get negative 5 is less than or equal to, and then a 6x. All right, divide both sides by that 6, and we get x over here and negative 5, 6 on this side. So what this states is that x is less than or equal to negative 5, 6. And how we're going to state that in interval notation, if you remember from the slides before, is if all of our values, I'm going to restate that, x is less than or equal to negative 5, 6. So, like I said, if you remember from the previous slides on how to state this in interval notation, it's saying that all of our values of x are less than negative 5, 6. So it begins at negative infinity and goes up to negative 5, 6. And since this is a less than or equal to symbol around the 5, 6, it's going to receive a bracket. And that's it. That's our solution in interval notation. Okay, so our next example is we have 2 inequality symbols in here. So how we're going to work with this is when we have this symbol here, we have to, whenever we get x all by itself in between the 2 inequality symbols, say we want to add 8. Well, we got to add 8 to all sides of this inequality. Okay, so we end up with 9 less than or equal to 6x, and that's less than or equal to 12. All right, same goes with multiplication or division. What you do to this middle to get x by itself, you must do to all sides of the inequality. Okay, so now this reduces to 3 over 2 less than or equal to x, which is less than or equal to 2. Okay, so now we have our solution here in our inequality form, but we want it in interval notation. That's how I'm going to make you state it all the time, especially on tests and quizzes. I'm going to want you to put this in interval notation. So when x is between two different values, and those values have a greater than or less than or equal to or greater than or equal to symbol, this is how we're going to write it. In a bracket, start with our lowest number, and then ends with our highest number, and place it in a bracket. Let's say our solution actually ended up being something like this. If we had 3 over 2 less than or equal to x, and then just a less than symbol 2. How this would look would be, again, bracket, start at 2/3, and then go to 2. But since this symbol right here is just a less than symbol, on our 2, we would put a parentheses rather than a bracket. Okay? So here's our solution for this one, though. All right, so let's move on to quadratic inequalities. So here's a quadratic inequality. What we're going to do with it, I have some steps on the next slide, but a quadratic inequality can be written like in this form right here. And what this is stating is our highest degree is going to be 2. Okay, and let's move on. So here are some steps of solving quadratic inequalities, and I will take you through these steps in my examples that I have. First, we're going to just solve the inequality that we see, the quadratic inequality, just like we would if it had an equal to symbol, just like if it was a quadratic equation. Okay? And then we're going to determine those solutions of that quadratic equation. And then we're going to test some values for each of those intervals, and I'll show you step by step of what all of this is in this next example. Okay, so for this example of solving a quadratic inequality, we're going to follow the steps. Step 1 is to find the values that satisfy this given equation right here. So basically all we're doing is replacing this symbol right here with an equal sign and solving for x. When we do that, this thing factors pretty easily. So it's going to end up being x minus 5, x plus 3. And then our x values end up being 5 or -3. Alright, so second step isn't necessarily needed, but I'm going to go ahead and put it in here just for my visual learners. I'm going to draw a number line and show you how this interval breaks up. Okay, so here and here, I'm going to say this is my -3, this is my 5. And what we're doing with our inequality up here is we are going to now just state the intervals for which we see on this number line. So everything less than -3 in interval notation is -infinity to -3. And then, we need to actually put a bracket on this because of our greater than, or less than or equal to symbol. And then same thing on this in between -3 and 5. It goes from -3 to 5, just like that. And then start back up, go to 5 to infinity, because everything greater than -5 is infinity. Okay, so there are 3 intervals, and I'm going to show you the next step on the next page. So here are all of my intervals that I just told you about on the previous page. And what we're going to do is we're going to see which one of these intervals are actually the ones that we need that satisfy our inequality, okay? In order to do that, what we're going to do is use test values. And see this interval right here? An x value that we can test in our inequality here is -5 because -5 is in this interval somewhere. Same goes with 0. 0 is in this interval somewhere, and 6 is in this interval somewhere. So we just need to pick a test value that is inside our interval, and then what we're going to do is plug it into our inequality. So we're going to say -5 squared minus 2 times -5 minus 15. And then this is less than or equal to 0. So what we're going to do is evaluate this left side of the inequality. And when we do that, let's see, we get 20. 20. Now, 20 is less than or equal to 0. That is not a true statement. So this inequality, or this interval right here, is false. So we're not going to choose that interval as our solution to this inequality since it's false. Okay, next interval, use the test value. Let's see, plug in 0 square minus 2 times 0 minus 15. Well, that's -15, which is less than 0. This is true. So this is actually one of the intervals we are going to use as our solution to this inequality. And then let's go ahead, do this last one. So our test value, 6 minus 15. And then that ends up giving us 9, which again, that is not a true statement. This is false. So the only one that ended up being true is this interval right here. So that is the solution to our inequality. That's what satisfies our inequality, is this interval right here, 3 to 5. Now, let's just change it up a bit because I don't have another example of a quadratic inequality. Say that this symbol right here was a less than symbol, or even a less than or equal to symbol. It would change all of these others then to the opposite. And our solution then for that one would be that this one would be true. Whoops, spelled true, right? And then this one would end up being true. And this one would end up being false. So how we would write our solution to this inequality would end up being that disjointed form of interval notation. We'd have to use that union symbol. And that would be our solution for that if our inequality here was turned the other direction. Okay? All right, next example, or let's look at some rational inequality. All right, so solving for rational inequalities. You may have done this in another class, and it's going to be a little bit different than what I may have taught you in the past, or some other teacher has taught you in the past. I do it a little differently. I like this book and the way it does the steps. It takes out a lot of the steps for us. So here are the steps. Read them if you want, but I'm going to show you each one of our steps as we go in our examples that we go through. So there's step 3. Okay, this is what I'm going to tell you. It says solving a rational equality such as this right here, 5 over x plus 4 is greater than or equal to 1, by multiplying each side by that denominator there to obtain this. It requires considering 2 cases. And since the sign of this right here is unknown, we got to consider that it's all negative or it may be positive, which changes the direction of our inequality symbol whenever we multiply or divide by a negative value. And so the procedure that we're going to use, the procedure that we're using in these next two examples eliminates the needs for considering separate cases, which is probably how you were taught before. And like I said, this eliminates it, and I think it will be easier for you guys. All right, so here we have a rational inequality. Normally in an equation, what you're going to do is multiply both sides by that x minus 3 in order to get rid of the fraction in this thing. But in order to follow the steps that I want you to do, this is how we're going to do it. Step 1. We're going to set this inequality less than or greater than or equal to, whatever the inequality symbol is, 0. So we're going to subtract 4 on both sides. Alright, so here we have this inequality, and now what we're going to do is get a common denominator. Okay, in order to do this, our common denominator is just going to be x minus 3. Okay, so this needs to be multiplied by x minus 3 in order to put x minus 3 in the denominator. Alright, so we have a common denominator, so we can put together our numerators. I'm going to come up here and do that. Okay, so 6 minus 4x minus 3 all over x minus 3. Okay, so let's put together all of this. I'm going to distribute. When we do that, I'm going to skip a step. We end up with 18 minus 4x over x minus 3. Okay, what I'm going to do in this next step is the reason why we are solving it this way. It eliminates those cases that we were talking about before. Okay, I'm going to rewrite that inequality again. What was it? 18 minus 4x is less than x minus 3. Alright, in order to do this step, what we're going to do is find values where the numerator or denominator is equal to 0. And remember, in this right here, our rational expression on our left side of this inequality, if our denominator is equal to 0, remember that is where we have what's called an asymptote. I remember if y'all know that, remember that from a previous algebra class, but that's where we're going to have an asymptote, and at that point there, our x value does not exist. So that's why we're including it in this these intervals in which we are trying to find. So I'm going to draw a number line here. We're going to end up finding two values. One of them comes from setting the numerator equal to 0, and then setting the denominator equal to 0, and then solving for x. So for this x value, we get 9 over 2, and then for this x value, we get 3. Well, remember, x equals 3, that is our asymptote, and that's going to receive, if we were to graph it, we would see it's not included in our number line here. It's not included in our values that we are looking for our intervals. And then this value, 9 over 2, that's included because of this symbol right here. It's a greater than or equal to symbol. So that is our 9/2, and this is our 3 over here. So our intervals that we are looking at for this inequality go from negative infinity, so values less than 3, to 3. And remember, this 3 is not included in our interval because it is an asymptote. And then we're going to say from 3, in between here, the 3 and 9/2, to 9/2. And we are going to include that value in our interval. So put a bracket around it. And then pick back up, go from 9/2 to infinity. And that's our last interval we're going to look at. And then the next step, I'm going to show you a table, and that's exactly how we're going to do it, just like we did in the quadratic inequalities. Which of these inequalities is true based on some test values. So let's test these values. Let's plug in 0 for our first interval. So we get 6 over 0 minus 3 is less than or equal to 4. Well, what we get here is that this is, what, negative 2? Yeah, negative 2 is greater than 4. Well, that is false. Let's go to the next one and test it. So we're going to plug in our value of 4 for our x, and then see if that's a true statement, which it is. We get 6 is greater than 4. That is true. So far, our solution to our inequality is this right here. Now let's see if this last one is part of our inequality at all by plugging in its test value. So let's see, 6 over 5 minus 3. And then, let's see, that ends up giving us 3 is greater than or equal to 4. Well, that is false. So, we have our solution is this interval right here, 3 to 9/2. And we are done with that one. So I'm going to go through these steps one more time with you in our last example here. Alright, so for this example, we start the same way. We are going to subtract that value of 4 from both sides of the inequality. And then we're going to combine those values by getting a common denominator. Okay. Alright, our common denominator again here is going to be just the 2x minus 3, the one that you see here in this denominator. Okay, so for this we get 4 times 2x minus 3 over 2x minus 3. So we got a common denominator. And then combining these, we need to combine our numerators. So what we're going to get is 3x plus 1 minus all of this that you see in this numerator. You can go ahead and distribute that 4 out if you want at this point, but I'm going to just do a shortcut again and go straight to, I know the numerator is going to reduce to this. And then this is our denominator. Okay, so this is the inequality that we need to deal with. And for the next step, remember, we are going to set both numerator and denominator equal to 0 and solve for those x values. Let's do that. So our numerator was this minus 5x plus 13. I'm going to set that equal to 0. And then our denominator was this 2x minus 3. I'm going to set that equal to 0. Alright, so let's solve for x. Here we get x is equal to 13 over 5, or, let's see, x is equal to 3 over 2. Alright, so let's draw out our number line here that we have. Here, at 3/2, it's going to be an open interval. Here at 13 over 5, it's going to be a closed one. And so our interval here ends up being from -infinity to 3/2. Remember, open interval because that 3/2 is not included. And again, start back up 3/2 to 13 over 5 and close it with a bracket because that value is included. And same here, 13 over 5, and it goes on out to infinity, positive infinity, and then close that up. Now, here are all three of our intervals that we are going to test on the next slide here. Okay, so testing these values, make sure your test values are in your interval or you're going to end up with some wrong answers. If you don't know how to tell what number or what test values included in an interval, make sure you come ask me and I can maybe explain it a little bit further for you, okay? Okay, so plugging in 0 for our first interval into all of our x values, let's see what we get. Looks like we're going to get -1/3. But I'm going to write it out. Okay, so yeah, we get -1/3 is less than 4. Well, that is a true statement. Okay, so far our interval includes this, right, our inequality that we are trying to figure out what values for inequality are equal to. That's included. And then let's see, for B, let's plug in test value of 2. And see what we end up with. Let's see, we end up with 7 is less than 4, which that is a false statement. So that is not an interval we're going to include as our solution. Now let's try 5. So we get 3 times 5 plus 1. And then 2 times 5 minus 3. That ends up being 16 over 7, which is less than 4. So we have another true statement here. So again, we have a disjointed solution for our inequality, and that ends up being our first interval here, up at the top, A, from -infinity to 3/2. Then union it, it's hard to say fast, with 13/5 to infinity. And we are done. Okay, that is all I have for you. Hopefully this wasn't too long, but I will see all of you in class. Y'all have a good night. Bye, everybody.